Tungal online classes. Today we are going to discuss about the concept of what? Pole strength. About the concept of pole strength. In the last lecture we discussed about the introduction part of the magnetism and matter, and we are also discussed the properties of the given bar magnet. So what are the main properties of the given bar magnet is? The first one we discussed, one is attractive property, and the second one is a directive property, and the third one is a what? Inductive property. In that attractive property we told that if you take any one of the bar magnet, that bar magnet will be attracting the magnetic materials such as iron, steel, cobalt, nickel. So what is the main principle of the bar magnet? Means whenever you consider any type of the bar magnet, it will be attracting the magnetic materials. So it is having some basic property that is called what? Attractive property. And moreover we told that if you take any one of the bar magnet, it is consisting of two poles. That's why we told that bar magnet will be acting as a dipole. Since it is consisting of the two poles, we are saying that the bar magnet will be behaves as a dipole. So and we are also defined the term pole. So what is the pole? How can we define the pole in the case of the given bar magnet? Means pole is the region at which maximum attracting power of the bar magnet will be concentrated. How can we define the pole? Pole is the region in a given bar magnet at which the maximum attracting power of the bar magnet will be concentrated. Such type of region, such type of a point we are calling as a what? Pole of the given bar magnet. Now how can we define pole strength? Strength means what? It is showing the ability of the pole. Strength means what? It will be showing the ability of the pole. So here we define the pole strength as it is the ability of a given pole of a given bar magnet. It is the ability of a given pole of a given bar magnet for attracting the other poles of the given bar magnet. Other poles of the given bar magnet are other magnetic materials. Such type of ability of a given pole is calling as a what? Pole strength. How can we define the pole strength here? So pole strength is defined as it is the ability of a pole of a given bar magnet. It is the ability of a pole of a given bar magnet for attracting the poles of the other bar magnets or other magnetic materials. Such type of ability of a given pole is calling as a what? Pole strength. So that is the definition of the pole strength. See here pole strength is one of the physical quantity. Pole strength is a what? One of the physical quantity. Why? How can we define the physical quantity? A quantity which is a measurable is calling as a what? Physical quantity. So here we are able to measure the ability of a pole, that is called what? Pole strength. So that here pole strength is one of the physical quantity and which is represented by the symbol small m. If you take the different physical quantities, they are measuring with different symbol. If you take the force, we are representing with the symbol of F. So here also the pole strength is measured or denoted with what symbol? Small m. And if you take any one of the physical quantity, it is having some SI units. The SI unit of the pole strength is ampere meter. The SI unit of the pole strength is a what? Ampere meter. So this is the SI unit of the given pole strength. If you have the SI unit, so you are also having some dimensional formula for the given physical quantity. The dimensional formula of pole strength is given by AL. So A stands for the ampere and the SI unit of the length is a what? A meter. Its dimension formula is a what? Capital L. So the dimensional formula of the pole strength is a what? AL and its SI unit is equal to what? Ampere meter. Now, so for the 2 marks question, how they will be asking regarding what? Pole strength. Simply they are asking on what factors this pole strength of the given bar magnet will be depends. So on what factors this pole strength will be depends means, first one is the pole strength of the given bar magnet. The pole strength of the given bar magnet is depends upon the nature of the magnetic material. It is depends upon which property? Nature of the given magnetic material. So how can we know the nature of the magnetic material means? All the materials are classified into three different categories. All the materials are classified into what? Three different categories regarding their magnetic properties, based upon their magnetic properties. So all the materials are mainly classified into how many categories are? Three different categories. Those are dia, para and ferromagnetic substances. For each and every substance, the pole strength will be changes depending upon the nature of that corresponding materials. So here the pole strength of the given bar magnet is depends upon what factor here? Nature of the magnetic material. Nature of the magnetic material. And the second point is what? Here, the pole strength of the given bar magnet is also depends upon area of cross section. Is also depends upon what? Area of cross section of the given bar magnet. First point is what? It is depends upon the nature of the magnetic material. Nature of the magnetic materials. Magnetic materials are mainly classified into three different categories. Those are dia, para and ferromagnetic substances. So first one is it is depends upon the nature of the magnetic material we have to chosen, and the second point is what? Pole strength is depends upon the area of cross section. Area of cross section. If area of cross section will be smaller, the pole strength is also small. If area of cross section will be small, the pole strength is also what? Small. If you consider the bigger shape, bigger sized bar magnets, the pole strength automatically will be becomes large. So that the pole strength is depends upon the area of cross section also. And the third point is what? It is depends upon the intensity of magnetization. Intensity of magnetization or limit of magnetization. It is also depends upon which factor? It is also depends upon what? Intensity of magnetization or limit of magnetization. Limit of magnetization. So if you take any one of the magnetic material, we will make them as a permanent magnets. So the strength of that magnets is depends upon the factor is that intensity of magnetization. Up to what extent we will magnetize them. Up to what extent we will magnetize them. Depending upon that, the strength of that magnetic metal will be depends. Such a phenomena we are calling as a what? Intensity of magnetization. What is the intensity of magnetization? By taking any one of the magnetic material, we will make them as artificial magnets. Such a process we are calling as a what? Magnetization. If we make them by more intensive, its magnetic properties will be more. If we make them by low magnetization, their magnetic properties are also what? Low. So that this pole strength is depends upon what factor here? It is depends upon what? Up to what extent that magnetic material will be getting magnetized. That only we are saying that up to what extent that a substance will be magnetized, or in terms of intensity of magnetization we are saying. So M is depends upon what factor? Intensity of magnetization. And so these are what? On what factors it was depends. On what factors it was depends. And the another factor is that the pole strength is independent of. The pole strength is a what? Independent of shape of the given magnet. The pole strength does not depends upon what factor? So here three factors we told that the pole strength is depends upon these factors. One is nature of the magnetic substance, second one is area of cross section, and the third one is what? Intensity of magnetization. So here what we are saying that the pole strength does not be depends upon what factor means it is independent of the shape of the bar magnet. Shape of the bar magnet. Suppose I consider the bar magnet. I consider the bar magnet which is in the form of a rectangle shape. Which is in the form of a rectangle shape. So here it is having the two poles. One is the north pole and the other one is a what? South pole. So in the case of the magnetic, what we have to remember that the pole strength of either south pole or north pole will be remain same. Here what point we have to remember that? We must remember that the pole strength of south pole as well as the north pole will be remain same. So that point we have to remember. Pole strength of south pole is equal to what? Pole strength of the north pole. Now, if this bar magnet will be bent, if this bar magnet will be bent in the form of a semicircle, or if you bend into the L shape or rectangular shape, whatever the shape. So, first what we take in the bar magnet is, it is in the form of a rectangular shape, and here we assume that the pole strength of either south pole or north pole will becomes what? Small m. Whenever this bar magnet will be bent into a definite shape, the pole strength of the bar magnet does not be changes. The pole strength of the bar magnet does not be changes. That only we told here. The pole strength of the given bar magnet is independent of the shape of the bar magnet. The pole strength of the bar magnet is what? Independent of the shape of the given bar magnet. It is depends upon only these three factors. Those are called what? Nature of the magnetic material, area of cross section, and intensity of magnetization, which is independent of what? Shape of the given bar magnet. So this is about pole strength of a given bar magnet. The next topic is the magnetic moment of a given bar magnet. Magnetic momentum of a given bar magnet. It's a very important. So before going to discuss about the magnetic momentum of a given bar magnet, once again we will recall the electric dipole moment in the case of the electrostatics. Electrical dipole moment. So what is the electrical dipole? It is a combination of two equal and opposite charges. It is a combination of what? Two equal and opposite charges which are separated by a definite distance of separation. Such combination we are calling as a what? Electrical dipole. So in the case of the electrical dipole, we define electrical dipole momentum as electrical dipole momentum is measuring with the symbol of capital P. So it is defined as, it is the product of the magnitude of the either of the charge. It is the product of the magnitude of either of the electrical charge and the distance of separation between the two charges, that is giving what? Electrical dipole moment. How can we define the electrical dipole moment? If you take the combination of two equal and opposite charges which are separated by some finite distance of separation, such combination we are calling as a what? Electrical dipole. So here this is a negative charge having the magnitude of small q, and it is also have positive charge having the same magnitude small q, and these two are separated by a distance of separation small 2a. Then we define that electrical dipole moment is simply nothing but the product of magnitude of either of the charge and distance of separation between the two charges. Here we told that electrical dipole moment is a vector quantity. Electrical dipole momentum is which type of quantity? Vector quantity. So if any one of the quantity we are saying as a vector quantity, we have to mention its direction. The direction of the electrical dipole moment. The direction of the what? Electrical dipole moment is always directed from negative charge to the positive charge. The direction of the electrical dipole moment is always from where to where? Negative charge to the positive charge. So this is the basic already we learned in the case of the electrostatics. Now, how can we define the term magnetic moment? So here we have to consider the magnetic dipole. We have to consider what? Magnetic dipole. So the magnetic dipole is simply nothing but a bar magnet I consider, because it is consisting of the two poles. It is consisting of two poles. One is the south pole, another one is the what? North pole. Now, in the last class, we mentioned two definitions. One is magnetic length as well as the geometric length. What is the magnetic length? The distance of separation between the two poles of the given bar magnet. The distance of separation between the two poles of the given bar magnet we are saying as a what? Magnetic length. So in the diagram, the distance of separation between the south pole and the north pole is mentioned as 2L. So this is the distance of separation between the south pole as well as the north pole. And just now only we told that if you take any one of the bar magnet, the pole strength of south pole as well as north pole will be remain same. If you consider any one of the bar magnet, the pole strength of the south pole must be equal to the pole strength of the north pole. So they will be having the equal magnitudes of pole strength, similar to the electrical dipole. When you consider the electrical dipole, you must consider two equal and opposite charges. Here the magnitude of the charges will be remain same. Here also the pole strengths of the two poles, south pole as well as north pole, will be remain same. Now, how can we define the magnetic moment? Means the magnetic momentum of a bar magnet. Will be defined as simply it is a product of pole strength of any one of the pole of the bar magnet. It is defined as how? It is defined as the product of the pole strength of any one of the pole, and the distance of separation between the two poles, So here the pole strength of either south pole or north pole will be taken as small m. The pole strength of either south pole or north pole will be taken as a what? Small m, and the distance of separation between the two poles will be denoted by 2L. Hence, the magnetic momentum of a bar magnet simply defined as it is a product of pole strength of the given bar magnet into distance of separation between the two poles, and it is denoted with what symbol? It is denoted with the symbol of capital M. Similar to the electrical dipole moment, this magnetic momentum is also a vector quantity. Similar to the electrical dipole moment, this magnetic momentum is also to be a vector quantity. So here the electrical dipole moment is directed from where to where? Negative charge to the positive charge. When you came into the magnetism, so here the south pole will be similar to the negative charge. South pole will be similar to what? Negative charge. As well as north pole will be similar to the positive charge. So in the case of the electrostatics, means we have two types of charges. One is a positive charge, another one is a what? Negative charge, we said. But in the case of the magnetism, it is having the two poles. One is the south pole and one is the north pole. So here we have to assume that the south pole will be similar to that of what? Negative charge, as well as north pole will be taken as similar to the positive charge. So for understanding purpose, we have to assume like that south pole is similar to the negative charge, as well as the north pole will be similar to the positive charge. So here the direction of the dipole moment is directed from negative charge to the positive charge. Means here also the direction of the magnetic moment is always directed from where to where? South to north pole. So from where to where the direction of the magnetic moment, we have to consider that the direction of the magnetic moment always to be considered from south pole to the north pole only. South pole to the north pole only. So we have to mention the direction of the M like this, from south pole to the north pole. So this is about magnetic moment. Once again, how can we define the magnetic momentum of a given bar magnet? Means it is simply defined as it is the product of pole strength of a given bar magnet. It is the product of pole strength of a given bar magnet and the distance of separation between the two poles. Distance of separation between the two poles. So the distance of separation between any two poles is always to be indicated with the what? 2L. So this is the definition of the magnetic moment. Now the SI unit of the magnetic momentum is ampere meter square. SI unit of the magnetic momentum is equal to what? Ampere meter square. How it is came? Magnetic momentum is a product of pole strength and distance of separation. The SI unit of the pole strength is a what? Ampere meter. SI unit of the pole strength is equal to what? Ampere meter, and 2L is nothing but a length into M. So ampere meter square. Like this we have to write the SI unit of the magnetic momentum is nothing but what? Ampere meter square. Similarly, the dimensional formula of magnetic momentum is, so ampere means capital A, meter square, that is nothing but a length square. Length is indicating with what? L. So AL square. So this is a dimensional formula as well as SI unit of the magnetic momentum of a given bar magnet. So this is about pole strength and magnetic momentum of the given bar magnet. Here, what we defined here, pole strength we defined and magnetic momentum of the given bar magnet we defined. Suppose I consider a bar magnet which is having the two poles. One is the south pole as well as the north pole. What we consider here? We consider a bar magnet which is having the two poles. One is south pole, another one is a what? North pole. I am assuming that the distance of separation between the two poles is equal to 2L. The distance of separation between the two poles of the given bar magnet is equal to what? 2L, and the pole strength of each pole is equal to small m. Pole strength of each pole is equal to what? Small m. Now, how can we write the magnetic momentum formula? Magnetic momentum is nothing but the product of the pole strength of the given bar magnet and the distance of separation between the two poles. Yesterday I told one word that if you break a bar magnet into any number of pieces, each and every piece will be acting as a individual bar magnet. Once again, if you break a given bar magnet into any number of pieces, each and every piece must be acting as a individual magnet. So if you take any one of the magnet, that magnet will be having two properties. Two properties. First one is a what? Pole strength. And the second one is a what? Magnetic moment. So if you take any one of the magnet, like that is a bar magnet, compass needle, or U-shape horseshoe bar magnet, whatever the magnet you consider, whenever you consider any one of the bar magnet, that a magnet will be having two properties. Those are the basic properties of the given magnet. One is a pole strength, another one is a what? Magnetic moment. Now, for understanding purpose, I consider a bar magnet. So this bar magnet will be split into two pieces. So whenever the bar magnet will be split into two pieces, as we discussed now, each and every piece will be acting as a individual magnet. Once again, what we taken here, bar magnet we consider. If you take any one of the bar magnet, that must be having the two fundamental properties. One is the pole strength and the other one is a what? Magnetic moment. So here I assume that this bar magnet will be having the pole strength small m, and this bar magnet will be having a what? Magnetic momentum capital M. Capital M. Now, that bar magnet will be divided into two equal parts. That bar magnet will be divided into what? Two equal parts. Initially, the distance of separation between the south pole as well as the north pole is equal to what? 2L. Whenever they will be cut into two equal parts, the distance of separation between south and the north pole of any one of the magnet will be indicated as 2L dash. Here 2L dash is indicating what? The distance of separation between the south and the north pole of new magnet. Here 2L is indicating what? Distance of separation between the south pole as well as north pole of the original magnet, what we assume. Now, I want to calculate the pole strength of the new magnet. I want to calculate what? Pole strength of the new magnet, as well as I want to calculate magnetic momentum of the new magnet. This concept is a very, very important. Once again, say what we taken here, a bar magnet is taken. When you took the bar magnet, it is having the two poles. Both the poles are having the same pole strength. And when you consider any one of the bar magnet, we easily measure that the distance of separation between the south pole as well as the north pole. That is also we mentioned as 2L. When you know the pole strength, when you know the distance of separation between the south pole as well as the north pole, you easily calculate the magnetic momentum of the given bar magnet. So, our assumption is what? The initial pole strength of the given bar magnet is small m. Initial magnetic momentum is equal to what? Capital M. Now, what we did, this given bar magnet will be cut into two equal parts. So, whenever you cut the magnet into two equal parts, those two pieces are acting as the individual magnets. Now, for each and every individual magnet, I want to calculate new pole strength value. As well as I want to calculate the new magnetic momentum also. Here, two points we have to remember that whenever a given bar magnet will be cut into any number of pieces perpendicular to its magnetic axis. Already we told in the last class, what is the magnetic axis? The imaginary line which is passing through both the poles of the given bar magnet. Both the poles of the given bar magnet. Such type of line we are calling as a what? Magnetic axis. Whenever a given bar magnet will be cut into, suppose we assume n number of pieces. Cut into what? How many number of pieces? N number of pieces perpendicular to the magnetic axis. So, the magnetic momentum of each piece remains same. Once again, whenever the given bar magnet will be cut into n number of pieces perpendicular to its magnetic axis, the magnetic pole strength of each and every piece will be remain same. When the bar magnet will be cut perpendicular to its length. Suppose whenever the given bar magnet will be, cut into n equal parts, parallel to the magnetic axis, the magnetic pole strength of each and every piece becomes m dash is equal to m by n. Once again say, when the pole strength of the given bar magnet does not be changes means, whenever the bar magnet will be cut into n equal parts, perpendicular to its magnetic axis, in that case, the pole strength of each and every piece, does not be changes. When the pole strength will be changes means, whenever the given bar magnet will be cut parallel to its magnetic axis, in that case only, the pole strength value will be changes. If this given bar magnet will be cut into n equal parts, parallel to its magnetic axis, at that time the pole strength of each and every piece, becomes to what? M dash is equal to m by n. So these 2 points we must remember. When the pole strength does not changes, when the pole strength will be changes. Simply, if you cut the bar magnet perpendicular to its magnetic axis, pole strength value does not be changes. When you cut a parallel to its magnetic axis, pole strength value will be changes. Now see here. So whatever the initial magnet we taken here, its pole strength value is equal to what? Small m. Now this magnet will be cut perpendicular to the magnetic axis, So hence the magnetic pole strength of a new magnet, does not be changes. Why? It will be cut perpendicular to its magnetic axis. That's why the pole strength of the new magnet, does not be changes. So that m dash value is equal to what? M only. Now, when you cut into two equal parts, the length of the new magnet will be changes. So here the length of the new magnet is indicated with what symbol? 2L dash. 2L is indicating what? Length of the magnetic length of the original magnet. So here 2L dash is indicating the magnetic length of the new magnet. So here magnetic length of the new magnet becomes to what? 2L by 2. Magnetic length of the new magnet becomes to what? 2L by 2. Why 2L by 2? Because it is cut into two equal parts. Suppose if it is cut into 4 equal parts, we will write 2L dash is equal to what? 2L by 4. 2L dash is equal to what? 2L by 4. If it is cut into n equal parts, at that time 2L dash is equal to what? 2L by n. So according to our assumption, it is cut into two equal parts, so that the magnetic length of a new magnet, 2L dash is equal to what? 2L by 2. Now, how can we calculate the new magnetic momentum? So magnetic momentum basic formula is equal to what? Pole strength into magnetic length. So here the magnetic momentum of the new magnet is equal to pole strength of the new magnet into its new magnetic length. Pole strength of the new magnet into what? It's a new magnetic length. So that m dash is equal to, I will write small m dash into 2L dash. Small m dash into what? 2L dash. Therefore, here m dash is equal to small m dash is equal to what? Small m. Magnetic pole strength does not be changes. So that is equal to small m, and new magnetic length of 2L dash is equal to what? 2L by 2. So this becomes to what? 2L by 2. So the new magnetic momentum M dash is equal to what? M into 2L by 2. But we know that M into 2L value is equal to what? Capital M. M into 2L is equal to what? Which is refers that initial magnetic momentum of the given bar magnet. Initial magnetic momentum of the given bar magnet. Therefore, M dash is equal to small m into 2L by 2. So, which is equal to what? M by 2. Which is equal to what? M by 2. So, finally what we got? M dash is indicating what? Magnetic momentum of the new magnet, each and every new magnet. So M dash is equal to what you got? M by 2. That means whenever the given bar magnet will be cut perpendicular to its length or perpendicular to the magnetic axis, which factors will be changes and which factors does not be changes. So whenever the bar magnet will be cut perpendicular to its length, pole strength value does not be changes. And which factor will be changes here? Magnetic momentum value will be changes. So whenever the bar magnet will be cut perpendicular to its magnetic axis, the pole strength value does not changes, but the magnetic momentum value will be changes. Those points we have to remember, that whenever the bar magnet will be cut perpendicular to its magnetic axis, how can we calculate new magnetic momentum value, how can we calculate the pole strength value, and which factors will be changes and which factors does not be changes. Pole strength value does not changes and the magnetic momentum value will be changes when it is cut perpendicular to its length. Now, again I consider one bar magnet, whose pole strength value is equal to small m, and its the magnetic momentum value will be assuming as a what? Capital M. So if you know the pole strength value, how can we define the magnetic moment? The magnetic momentum of the given bar magnet is equal to what? Capital M is equal to small m into 2L. So simply product of the pole strength into distance of separation between the two poles. So when you know those two values, we simply calculate the magnetic momentum of a given bar magnet. So in the previous case, how can we divide the bar magnet into two pieces? We cut the bar magnet perpendicular to its magnetic axis. Now, in this case, I consider the bar magnet, whose magnetic momentum is equal to capital M and the pole strength is equal to what? Small m. I consider one bar magnet, so which is having what? Two poles. One is a south pole, another one is a what? North pole. For the bar magnet, what we consider for that bar magnet, pole strength value is equal to small m, small m, and magnetic momentum value is equal to what? Capital M. The distance of separation between the two poles is indicated by 2L. Now, this given bar magnet will be cut into two equal parts. This given bar magnet will be cut into how many parts? Two equal parts. So how can we cut into two equal parts? Parallel to the magnetic axis. How can we cut the given bar magnet into two equal parts? We cut the bar magnet into two equal parts, and how we cut the bar magnet? Which is a parallel to the magnetic axis. So when you cut the bar magnet, so it is looking like this. So this is the first magnet and this is a what? Second magnet. First magnet and second magnet. So whenever you cut a given bar magnet into any number of pieces, each and every piece will be acting as a individual bar magnet. So whenever you cut this bar magnet into two equal parts, these two magnets are also having south pole as well as north pole. South pole as well as north pole. In the last topic we told that whenever the bar magnet will be, cut perpendicular to the magnetic axis, we told that the pole strength of the given bar magnet does not be changes. Pole strength of the given bar magnet does not be changes. But when you cut the bar magnet parallel to the magnetic axis, the pole strength of the given bar magnet will be changes. Once again, when you cut the given bar magnet, parallel to its magnetic axis, pole strength value must be changes. How the pole strength value will be changes? The pole strength value will be changes according to the relation m dash is equal to m by n. M dash is equal to what? M by n. Where n stands for how many number of pieces you made. Suppose if you made 10 number of pieces, the pole strength of each and every magnet, becomes to what? M by 10. But in this case, the given bar magnet will be cut into how many pieces? 2 number of pieces, so that the pole strength of each piece becomes to what? M dash is equal to m by 2 for the first magnet, m dash is equal to m by 2 for the second magnet also. Once again, whenever the given bar magnet will be, cut into n equal parts, parallel to its magnetic axis, the pole strength of each and every piece, is equal to m dash is equal to m by n. From that relation, because here the magnet is cut into two equal parts, the pole strength of each and every piece becomes, m dash is equal to m by 2 comma m dash is equal to m by 2. So pole strength value will be changes. Now coming to the length, magnetic length. So because you cut the magnet into two equal parts parallel to its magnetic axis, so the distance of separation between south and north pole of the first magnet and the distance of separation between south and north pole of the second magnet also be remain same. When you cut the bar magnet parallel to its magnetic axis, which physical quantity will be remain same means magnetic length value will be remain same. When you cut perpendicular to the magnetic axis, which quantity will be remain same? Pole strength will be remain same. But in this case, when you cut the magnet parallel to its magnetic axis, which quantity will be remain same? Magnetic length will be remain same. So how can we calculate magnetic momentum of the each and every piece? So magnetic momentum of each and every piece will be indicated by m dash. M dash can be written as small m dash into 2l dash. Small m dash into what? 2l dash. Here small m dash value is equal to what? M by 2. Small m dash is equal to what? M by 2. Why? Because it is cut into only two pieces. That's why m dash value is equal to what? M by 2. And here the magnetic length value does not be changes. So here 2l dash becomes 2l only. 2l dash becomes to what? 2l only. So the new magnetic momentum of the each and every piece is equal to what? M dash is equal to m by 2 into 2l. Now so it can be written as m dash is equal to 1 by 2 into small m into 2l. So small m into 2l already you know that, which is indicating the magnetic momentum of the original magnet. Therefore the magnetic momentum of each and every piece the magnetic momentum of each and every piece becomes to what? M dash is equal to M by 2. M dash is equal to what? M by 2. Suppose if you cut into 10 number of pieces, if you cut into 10 number of pieces, so M dash is equal to what? M by 10. If you cut into N number of pieces, N number of pieces, M dash becomes to what? Capital M by N. Like that we have to calculate magnetic momentum as well as pole strength of each and every piece of the bar magnet whenever it is cut either perpendicular to the magnetic axis or parallel to the magnetic axis. This is about pole strength and magnetic momentum of the given bar magnet. Thank you.